Hello, welcome to the very first video in a computer science and programming video series like no other. If you are looking to actually learn computer science and programming, you have come to the right place. This is not another video talking about the pros and cons of being a software developer, how much I make in a year, or what the best programming language is currently. My goal in this series is to create the best freely available programming and computer science content on the web. We have a lot to cover in this video, so let's jump right in. I'm going to start today's video by taking a little time to introduce the course and the topics and what you can expect to get out of your time invested in taking this course. I also want to mention that the only prerequisite skill you need in order to continue is the ability to use a web browser and simple web navigational skills. If you found this video and you're watching it, you should be fine. We're going to start by talking about some really important topics, namely what is computer science and programming? What are these two things and what is the relationship between them? We are then going to explore how to write an algorithm, which is basically a recipe for solving a problem. It's how we tell the computer to carry out our instructions. And we're going to start by right away examining what makes an efficient or good algorithm versus ones that are poor. We'll start today using something called pseudocode to express how we create machine instructions to tell the computer to do something. Pseudocode is similar to coding, but it's just more natural, more like natural language. In pseudocode, we'll explore what is a statement, a variable, and conditionals. These are all constructs we use when we're programming. Once we understand these fundamentals, we're going to take our pseudocode and transform it into an actual programming language. Today we're going to use JavaScript, but I'm not going to strictly stick to any particular programming language within this course. I think it's very important that right from the beginning, students are comfortable with switching between programming languages. I'd like to just take a quick moment to introduce myself. My name is Brian Gormanley, and I'm a computer science professor. I believe that there are three fundamental aspects to learning computer science and programming that are necessary to be successful. The first is theory. Now, I was initially a self-taught programmer. In middle school, I took one course on BASIC, but I really learned from books, finding code, and just reading and experimenting. But those efforts only got me so far. There was much that I still did not know. Back then, there weren't quite as many resources available on the internet, and I honestly wanted to go to school. I wanted the full experience. So I went and got my computer science degree. Getting a computer science degree is definitely one good way to solidify the theory part. But there's much more to computer science than just theory. The second component that I'm passionate about is practice. I have plenty of computer science students who are very book smart, but they don't write enough code, and they don't end up being successful. I like to think about like playing a musical instrument. If you want to be a master of guitar and you want to be up there rocking with Metallica, then you gotta put in the time to practice the guitar. I can teach you music theory all day, and music theory will make you a better musician. However, you have to practice. Your success is dependent on you practicing the guitar. It is no different in computer science. You must practice coding. The last thing I want to discuss is community. Programmers are often thought of as introverted, and I have to tell you it's a little bit of an unfair stereotype. But the truth is, we think of it as a solitary exercise. At a very early point in my career and in school, I was involving myself in open source projects, both on the web and creating my own. I also got involved in online communities where like-minded people were gathering to solve problems. I frequented a forum where enthusiasts were building what were called car computers or car PCs. This was in a time before cars had infotainment systems. We didn't know it, but we were building the precursors of these infotainment systems. We'd install computers in the car and build elaborate fiberglass contraptions in the dashboards to house screens in. We had to spec the right hardware so that you could see it in the sun and it would run on DC power. And we had, most importantly, to create software. At the time, remember, the mobile revolution hadn't even happened yet. When you thought computer, you thought Windows and you thought start menu. And if you're driving, there's no way that you're going to open a start menu and find an application and somehow use the file menu and a cut-paste. We had to innovate and create software that made sense to be used in the car.
These experiences very much changed how I thought about my role as a software engineer. I now saw myself as someone who could create to solve real problems in the world. It is because of community that I took this leap. And it's also because of community that I went on to start my own startups, get involved in robotics, and all other kinds of hardware projects. So now that we've discussed these three important parts, I want to acknowledge that in an online setting, two of them can be rather difficult. I can create videos to explain theory, and there's even certain advantages to this medium because you can slow me down, speed me up, or pause me in return. However, when it comes to practice and community, there are some challenges. On the practice side, the traditional methods of me doing assessment on grading of homework and projects is a little bit more difficult. However, I am going to introduce projects along this course because that is the practice and the engagement. Now, what I implore you to do is if you don't choose to do the projects that I add to the courses, please choose and do your own. And as part of this and community, please talk to me. Talk to me and talk to all of the other students who are taking this. Tell us what you're up to, share your ideas, get feedback. These are the most important parts. These are the parts that push you forward and evolve your skills to the next level. All right, enough about me. Let's start the community right now by learning about you. Please go ahead and introduce yourself in the comments below. Let me know what you hope to get out of this course.
All right, so now that you know a little bit about me, I'm going to take a few moments to explain how I've structured the course to try to make these things happen. How are we going to bring in community? What ways are you going to get to practice? That's up in the next section. All right, so the first thing I want to talk about is how I've structured the content. Very commonly, computer science is taught one of two ways. It's taught university style, where you take discrete concepts and bang on them. So you're working on data structures, or you're working on algorithms or AI, or perhaps you're doing software development. On the internet, it's a little bit different. On the internet, almost all of the material you see, at least on the made for the internet side, is tutorial based. It's how to learn JavaScript in 20 days or become a Python master. Well, there are plenty of courses out there that are university courses that have been filmed or produced and then put on the web. There really isn't a whole lot out there that was produced for the web, and that's what I'm trying to do here that's a little bit different. Now, this is going to be a challenge, and I fully accept that it might grow and change as time goes on. I'm going to try to weed out what works and, grow that and look for what doesn't, and I might have to make some changes. But for now, I've got some ideas on how to get started. The first thing I want to do is talk about three principles that I've used to think through how I'm going to present the content. The three core principles of this course are no magic, no unnecessary complexity, and fundamentals first. So what do I mean by these things? By no magic, I'm going to avoid ever saying things like, don't worry about this for now, or we'll talk about that later. I think that's a bad experience for the student. When the student is asking that question, when they're wondering about that fact, that's the moment where their brain wants to make the connection. And if we deny that knowledge at that moment, we're losing that opportunity possibly to make the connection and grow from it. I'm trying to structure the content in such a way where I simply don't have to say those words. Now, computers are very complex in some ways, and obviously this can be a challenge. So how I structure this course is going to be significantly different than conventional. I'm going to take an approach where I mix both practice, software development, and theory hand in hand. In most computer science courses, a lot of the topics that I'll discuss intermingled with the development experience here would be their own separate course. So data structures, for example. Here, we're going to talk about them as we start to use them. And I'm hoping that if I take this approach, we can discuss how a computer works, get down to the fundamentals of just binary and arithmetic and how we encode data and all of these pieces actually while we program, so that when you're learning how to use a data type in a programming language, you're also learning how it works under the covers inside the computer. Now, at the same time, I'm going to strive for no unnecessary complexity. So what do I mean by that? I think the best example of this is when you take a programming tutorial and they want you to say install Java
and an IDE. Well, it's been my experience that many people that I know who have tried these things give up or walk away because it's a frustrating experience to have to do that when you're coming in blind. And you don't necessarily have an introduction to programming course or something like that under your belt that helps you with the basic concepts of even explaining adequately what an IDE is. So I'm going to leave that all to the side. I've been very careful to find ways that we can start programming right away that require almost zero prior knowledge. That's why I said at the beginning of the course that all you need to start today is experience using a web browser. I've located tools on the web where we can go and program, and then we're going to work up to installing different development environments, managing IDEs, learning about repositories like Git. But for day one, we're going to avoid all of that. The last principle here is fundamentals first. Now, this one refers to starting at the basics and understanding, most importantly, how the computer works in conjunction with how your code works. We know that computers are very complicated, and in computer science, we use something called abstraction to try to mask that. One of the videos that I'm going to ask you to watch after this one for this week's kind of take-home assignment, your practice, is a video on abstraction. Abstraction is there for a reason, because computers have many layers of complexity, and it would be almost impossible for any one human to master them all. We build these layers of abstraction with what are called interfaces, which is where you and I use the layer of abstraction, or one layer of abstraction interfaces with another, and that's all we really need to know in order to master what we're doing. But if we want to be effective engineers, we really need to have a high-level understanding of what's happening down those layers of abstraction all the way to the inner hardware of the computer. So I've baked that into this course. Now, this doesn't mean that we're going to be starting programming in assembly language. We're going to start programming in high-level languages just like you would in any other computer science curriculum. However, we're going to take a focus of what we're programming and use that to reflect how a computer actually works. So, for example, when we talk about things like Boolean data type, a Boolean data type is a true or false. We're going to talk a little bit about the transistor and how it represents a 1 or a 0. That perspective is going to come up through the whole course. So some other things you should know about the course. In order to promote as much community as possible, I've organized a bunch of resources that are at the end of the slides. So when we get there, please check them out. But they include resources like OSSU, which is a open source community that is creating a computer science curriculum that is meant to be followed by people who are online and out of school. They also have a great Discord community, and that is yet one more avenue that you can explore to help get you involved in that community piece and help promote practice. They also promote creating your own projects, and they even have a large final project if you do their degree program. I'm also going to be creating community of my own. Please look for that. I'm going to have information in the description below here. I'm thinking about setting up a Discord community, and again, I'm just playing with what is going to work for this course. Things might change as this evolves. And project-wise, there will be projects in this course. Now, I'm going to evolve that as this progresses. I'm not going to talk about it a whole lot on day one because honestly, I don't want to scare anyone off. What the purpose of these first lessons are is to get your feet wet, to teach you the main concepts, and to start that growth. As we progress, you're going to be ready for projects, and as you are, we are going to do them. I'm going to do my best to be as involved as I can for a teacher on the internet. Part of my battle here is to find creative ways to do that, and I'm hoping to grow that as we do. I also want to mention that I'm growing my channel to contain computer science content at all levels. That means that I'm going to be posting videos that are, more intermediate and advanced, as well as these videos. What I want you to know is that if you're just starting out, those videos are not meant to imply that that is like your next step. I'm going to have these videos marked as the CC100 series, and they're all going to be numbered, so you can follow along. This is obviously the introduction lesson and lesson 1. So what better way to start a course on computer science and programming than to put both terms on the screen and to define them next to each other? Computer science is a much broader definition than programming. Computer science refers to any techniques that we use to solve problems involving computers. Programming is one of those tools in our toolbox that allows us to solve these problems. It allows us to create programs which are instructions for the computer. I think computer science is a bit analogous to something like woodworking. If you are a woodworker, you might be making cabinetry, you might be making grand staircases. Effectively, you need to learn things like joinery, which is how you bring pieces of wood together. You need to know how to choose the correct wood for a project and how to align the grain. You need to have a good understanding of basic arithmetic, but you also need to know algebra, geometry, calculus, and statistics. Not only do you have to know math and be good with your hands, but you also have to have an eye for design, understanding of tried and true designs, and a little bit of artistic vision to make it all come together. You also have to be willing to put in the time to learn and use many different tools, including computerized tools such as CNC machines and more basic ones such as hammers. So I believe computer science is really no different from this. I look at programming as one of the tools in our toolbox. Computer science encompasses many things, from networking to artificial intelligence, computer security, algorithms, compression, networking protocols. The list goes on and on and on. Not all of these things are explicitly solved by programming. Programming is a major tool we use, especially as software engineers, but it is not the entirety of computer science. The next important term I want to explore today is an algorithm. An algorithm is a step-by-step of operations that we're going to perform in order to solve some kind of problem. What makes this different from a computer program is simply that a computer program may contain one or more algorithms. An algorithm is a discrete problem that we're trying to solve, but a computer program may encompass more than one. We're actually going to start today by creating our very first algorithm. We are going to create an algorithm that mimics a thermostat. Now, a thermostat, of course, checks a desired temperature against the current temperature and then makes a decision on what the hardware, whether it's your heating system or your AC system, needs to do to correct any difference between these two things. This is also known as the error, by the way. Algorithms can perform their work in many different ways, and it's important as a computer scientist to consider your algorithm carefully. Now, I'm going to take a little bit of liberty here with the hardware of the heat and the air conditioning systems and how much flexibility we have in controlling their output, but I'm doing this to make a point while sticking with the introductory algorithm that we're going to be using today. Let's say that our set point, what we want the temperature to be, is 70 degrees and the current temperature is 69 degrees. Well, our algorithm can determine the difference between these by performing the math and realize that we are at a deficit and that it needs to turn on the heat. We have choices, perhaps, in how we respond. We could turn the heat on full blast and possibly overshoot the set point, which would then mean that we would have to turn on the air conditioning to compensate. This could end us in an endless loop of needlessly wasting electricity and fuel. Or we might be able to take a different approach. Perhaps we can write a proportional response. Given the amount of error, we can turn on the heat just a little bit or the air conditioning just a little bit. This is just one way to think about how an algorithm can be right or wrong. Next, I want to talk about algorithm efficiency. This is also known as Big O notation. What algorithm efficiency refers to is the fact that not all algorithms are created equal. And as computer scientists, it's very important that we strive to use the most efficient algorithms possible. Inefficient algorithms can become what's known as intractable, or basically not solvable in a reasonable amount of time. There's a TED video in the references that gives a good example of this. They use an algorithm as an example where a person is just counting people in the room. If we imagine that there's 10 people in the room and you count them one at a time, you've taken 10 steps to count all the people. You always know that your algorithm will be correct because you took the time to count the people one at a time, but it took you 10 steps. However, we could count people 2 at a time. We could go 2, 4, 6, 8, and 10. Well, in this case, we've halved the amount of time that it took our algorithm to produce the results, so we've made a more efficient algorithm. But a problem comes if we have 11 people, because if we count In 2's, we might not get the correct result. We might end up with 10 or 12, depending on how we wrote it, but we won't end up with 11, which is the correct answer. So as a computer scientist, our job is to be creative and to find the correct algorithm that is also the most efficient. Let's use another example here to drive this home. Imagine you're driving down the road and you're looking for an address, and you know the length of this road, you just don't know where the house is. You also know that the numbers on this road start at 1 on the end of the road that you're on, and that they go to 1,000. And you know that the address you're looking for is number 750. You could drive very slow and check every single mailbox as you drive down this road, and that would take you 750 checks before you were correct. Or perhaps we could check when we get about halfway down the road to kind of confirm that we are in fact around address number 500, and then check again when we think we'll be around address 750. It is possible that we could overshoot a little and we might have to go back, but this would still likely be a much more efficient approach than bothering to check every address as we drive down the road. What this is an example of is what's known as a binary search, where you're actually having the amount of possibilities and then exploring within the correct half until you find the right result. All right, so now that we know what computer science is, and we know what a program is, and we know what an algorithm is, let's actually start trying to code an algorithm. We're going to start today with what's known as pseudocode. Pseudocode is just a way to express instructions that are going to make up our program without actually applying a specific programming language. Pseudocode is meant to help you express ideas and evolve your algorithm before you actually put it into practice. We're going to start today by using pseudocode to create the algorithm that mimics our thermostat. The first thing we need to know to create a line of code is to understand what we would call this line of code, and the answer is that we're going to call it a statement. A statement is simply an expression of some action to be carried out. It could be something like print hello world in my pseudocode example here, or it could be something like 1 + 1 = 2. A statement is just one discrete action that we're going to take. Another important concept that I want to get to right away is that of a variable. In a computer programming language, a variable is simply a container that you're going to put some value in. So what do I mean by that? Well, let's look at these examples here. In my pseudocode assignments here, I'm creating a variable in the first line called temp, and I'm assigning it the value 65. So this means that later in my code, when I refer to the temp variable, what I'm really referring to is the value that I've put inside there, namely the 65. If I ask the program to display the value of the temp variable, it will show me 65. What I've listed here now are the variables that we will need in our pseudocode thermostat in order to make this work. This is actually the first lines of our program. The first line, again, we're just setting the current temperature here. I've abbreviated it to just temp, T-M-P, to be 65. And we're creating another variable to hold on to what we want the desired temperature to be. This is what the user has set on the thermostat. We then determine the difference by taking the current temperature and subtracting the desired temperature. And whatever the result is, we're going to assign to a new variable called difference. So we've created 3 variables here: temp, desired temp, and difference. Notice that temp and desired temp we've hard-coded. We've put these values in there. Now, obviously, in a real thermostat, the desired temperature would be changed by the user as they use the controls to set the desired temp, and the actual temperature would be set by some kind of sensor that was reading the temperature in the room. Our third variable, the difference, notice we set that here using our statement. We take the temperature, we subtract the desired temperature, and we take that value, which in this case is -5, and then we put it in the difference. The last piece we need to know today to complete our algorithm is what a conditional statement is. A conditional statement in programming is simply a decision. I can say, if something is true or false, then I'm going to take some action. We commonly denote this with the term if. So in this example, we take that difference that we know from our last slide is currently -5, although if the temperature or the desired temperature were to change, that value could change, which is why we use variables, because our code doesn't necessarily know exactly what the value is going to be. If it did, it wouldn't be a very useful program. So we can imagine that our difference here is currently -5 based upon the data that was entered. We have -5 is less than 0. So we're asking, is this true? Is -5 less than 0? If the answer is true, then we're going to perform the indented action below it, which is turn on the heat. In this case, that is true, right? A -5 is in fact less than a 0, so we are going to turn on the heat. Now notice the line below it says otherwise, if the difference is greater than 0, turn on the AC. The otherwise is important. This is also going to be commonly used with a term called else. I've used otherwise here because we're using pseudocode, and I wanted to give an opportunity to show you different variations. But basically what we're saying here is that we're only going to consider this condition if the first one was not true. But since the first one was true, that the -5 was less than 0, we're not going to worry about this one because it's an otherwise. If I took the otherwise out and I just had if difference is greater than 0, it still would be false, but we would have considered it. We would have evaluated it to see if we should do it. Since we had the otherwise, we didn't even evaluate it. We just moved on. Similarly, at the bottom, we have another otherwise if. And this is basically to see if we've accomplished our goal of reaching the right temperature. The difference is 0, nothing to do. Let's explore this just with different values and difference to see what happens. Let's imagine that our difference was a +2 and not the -5 that we had in the previous slide. So in this case, I would go to the very first statement and I would say if 2 is less than 0. Well, that is false. 2 is greater than 0. So I do not turn on the heat. I would then move down to the otherwise if 2 is greater than 0, which it is, and that is now true, which means that I do turn on the AC. Because my last statement, again, is an otherwise, and one of my conditions above it were true, then I don't even bother to evaluate that statement. Lastly, let's consider if difference is 0. So if difference is 0, the first statement is going to be false, because remember, this is not less than or equal to 0. This is if difference is less than 0. So 0 less than 0 is false. If it were 0 less than or equal to 0, then it would be true, but it's not. So I'm going to skip that if statement, and I'm going to jump down to the otherwise if difference is greater than 0. Again, this is still not true because 0 is not greater than 0. Now I'm going to go down to the third condition, and that one is true. If difference is 0 is true, then there's nothing to do. All right, congratulations. We actually have all the pieces we need to make our thermostat algorithm. Now we're going to take our pseudocode and we're going to learn to translate this into an actual programming language. Today, again, we're going to be using JavaScript, but I may change this from time to time. I want you to understand that programming languages are not the thing that you're learning here. You're learning how to program. Programming languages are simply tools in your toolbox that you want to be comfortable with changing when necessary to use the right tool to complete the job. Different programming languages have different strengths and weaknesses depending on what your goals are. So what is a programming language? Well, a programming language is just a discrete set of instructions that implement algorithms to produce an output. It's important to note here that they need to be completely unambiguous. They need to express exact meaning. Unlike the English language, where we have a lot of words that have two meanings, you cannot have a statement in a programming language that has more than one meaning. The computer will not know what to do with that. Believe it or not, a computer is nowhere near as smart as you or I. It only understands discrete actions. And if there's more than one possibility, then that would lead to errors. Programming languages are defined by what is known as syntax and semantics. So the syntax of a programming language represents its structure. It represents all the things you have to do to make it a valid statement. So for example, some programming languages require a semicolon at the end of a line.
Statement.
That is part of the programming language's syntax. Other programming languages do not necessarily require that semicolon. The semantics of a programming language are the meaning behind it. Now, this is best expressed with an example. Let's look at these programming statements. The very first statement here is let a equal 5. We now know that a is a variable, and we are assigning it the value 5. Now, below that, we have a minus 4. Well, this makes sense. Semantically, I can take 5 and subtract 4. That is not a problem. The next line is let a equal a string, or Brian. Now, if you look right below it, I do the same exact thing that we did with the previous example. I have a minus 4, but now a is not a number. A is a word. A is Brian. Brian minus 4 does not make sense. This means that both of these little examples here, the first one, let a equal 5 and then a minus 4, and the second, let a equal Brian and a minus 4, both of these are syntactually correct. There is nothing that makes them wrong in the particular programming language that we are using right now. However, semantically, the second one makes no sense at all. Now, it's important to note that semantics do vary between different programming languages. For example, if I had actually said a plus 4 instead of minus 4, depending on the programming language, it might actually have been semantically correct. And that is because some programming languages would have taken the 4 and done what's called a concatenation. They would have added the 4 to the string. So we've actually learned all we need to know. Now we're going to take our pseudocode and we're going to translate it to create our very first program. Again, this is going to be done in our JavaScript language, and I have a link right below here in the description to the online editor that I'm going to use. Please make sure to follow along in the video, and don't be afraid to pause the video as you go through this point to make sure that you're doing all the steps. I also want to note that it is possible that the online editor might look slightly different when you're watching this video. Online software gets updated over time, and I'm also including the link only below just in case I need to change it or I evolve into a different editor in the future that I find that's better.
Okay, so I'm in my online editor and I've removed any code that was already there to start with a fresh screen. The first thing I want to do is create a statement. So as we said, a statement is a single discrete action that we want our code to carry out. And the statement that we're going to write is one where we assign a variable. So remember, we're going to create our thermostat, and to do that we're going to want variables that both keep track of the current temperature and the desired temperature. So in JavaScript, the way I do that is with a statement called let. Let is simply a way to declare a variable. So I'm going to name my variable temp. Remember that you can name your variable anything that you want. However, you want to make sure that you name it something that makes sense. If you call your temperature value Stanley, that might not make sense to anyone else reading your code. And readability in your programming is very, very important. It is what helps other developers actually be able to understand your code. So that's one variable. I'm going to repeat this process now, and I'm going to create a second one. As I do, I want to point out that I added a, let's call it desired temp. Like this. I want to make a couple of things I want to point out about this statement here. So the first one is that notice I've ended both of these statements with semicolons. Now, JavaScript does not actually require this, but a lot of programming languages that share similar syntax with JavaScript, which is known as C syntax, do require using a semicolon. So it is actually a pretty good practice to do, although there is no reason in JavaScript why you absolutely have to do it. It is actually a choice. I'm going to do it here to be clear, and just because these statements are very similar to ones that you might find in other C syntax language, I would like them to be as portable as possible between what we're doing here in JavaScript and possibly other C syntax languages as well. The other thing I want to note is that I named this here desired temp, but you'll notice that I have a capital T. Now, this is not part of the syntax. This is actually a convention. So it is a stylistic choice on how you want to name your variable names or anything else as we progress, like function names and class names, as far as whether or not they should have capitals and where, or if they should have underscores or possibly even hyphens, which will not work with JavaScript. Different languages do have different syntax rules which will restrict your choices. So for example, I cannot use a space here in JavaScript. That is not allowed. I can use an underscore, and that is something that a lot of people do. But I am using the most common convention here, which is called camel case. You start your words with a lowercase letter, and then every new word that you're adding to the previous one starts with an uppercase letter. There's a variation on this where you would have capitals for all of the words, including the first, but the most common version of this, and definitely the one that you see in JavaScript most often, is regular camel case, where the first letter is lowercase of the first word. All we've done now is we have two statements. They both declare variables. So we have variable temp, which is currently equal to 65, and we have a variable desired temp, which is equal to 70. This is very similar to the pseudocode that we created. Now I'm going to create a third statement, and this statement is going to let us figure out the difference between these two things. So I'm going to declare, remember that's what that let keyword does for us. It declares a variable named difference, and this variable is going to be equal to the actual difference, the subtraction of the temperature minus the desired temperature. So now this value, remember, could change. And now remember, these 65 and 70 degree values for us now, we're hard coding them, but a real thermostat, of course, would be supplying the actual temperature, like we said, with some kind of temperature sensor, and the desired temperature could be changed by the user by using the keypad, right? So the values that are contained within these variables would change based upon the sensor and the user input. This third variable now is simply going to get the difference between these two things and keep it. Let's now see the fruits of our labor so far. Notice that I added an extra space here. Again, this is just a choice to make it a little stylistically easier to see. There is no problem as far as syntax for JavaScript if you skip a line like this. You can leave blank space. In fact, it's recommended to leave blank spaces to kind of group areas of code that work together, so it helps you visually kind of see, like, okay, well, those three kind of go together, and now I'm going to do something else. And the next line of code here that I'm going to write is one that is going to give us some output. This is something that you have not seen before. So what I've done here is I've typed, obviously, console.log, and I want to take a moment to explain what these things are and why we are using them. So console is an object. Now, we're not into object-oriented programming yet, but as I promised, there is no magic here. So we're going to take a moment to talk a little bit about that. I have a link in the resources that will bring you to the documentation on the console object. And if you look there, you'll see that there are many what are called methods that are available on console that you can use to accomplish different tasks. This object is provided to you as what's called a library object. The JavaScript programming language provides this object and its methods, the actions that the object can perform for you, so that you don't have to rewrite them yourself. So what this particular method does is it actually provides output. So for example, if for now we just say, let's look at the difference, and we run this up here, we can see that we get a -5, which is exactly what we expected to happen. So just to recap here, I have an object, that is this console, and don't worry, we'll be diving a lot deeper into these as we evolve through our sessions. This object has a method called log, and this method has code in it that knows how to provide this output in this box here. And that's known as a library function. As a programmer, you're going to use this a lot. You're going to learn how to reuse code from other locations so you don't have to reinvent the wheel every time you want to do something as simple as maybe provide some output. So we're going to use this object and function now just to kind of do a few different things and to see some of the options that we have to provide output. So right now we're seeing that our mathematical equation worked exactly as we expected. Let's just see what happens if, say, the temperature instead was higher at 72. If I run this, I get the expected output, which of course is 2, right? So that works. So let's go ahead and put this back to where it was. Now I'm going to do something different here. Instead of putting the variable name, and remember, when we do this, when we reference a variable here, just like this, we're expecting that the value is what we're going to get back. And that's in fact what happens, right? That we get the value out of that. Now, what if we replace this with what's called a string? You can actually do this with double quotes. So I'm going to put my name in here. Or you can do it with single quotes. In JavaScript, either one is correct. I'm going to go ahead and run this, and you can see that in the output there, it now says Brian. This is how most demonstrations like this have the very famous hello world that they do. You can see if I replace Brian with hello world, of course you get hello world, and that's great, but that is not exactly what we want to accomplish here. We're building a thermostat. So let's go one more step here. Let's take this to the next level. Let's have this say it is currently, and notice I'm going to put a space here, and you'll see why in a moment. Now I'm going to do something called concatenation. Now, what concatenation means is that I'm going to take things and basically string them together. In this first segment here, over here, I have what is known in programming as a string. These are words in natural language that we are showing on the screen. Now, they are saved differently inside the computer than a number, right? You can't perform math on a word, for example. So in order to show the words and numbers together, I'm going to use something called concatenation. Now notice here that this is a plus sign. If I had a number and a number, this would actually do what you would expect it to do and add the numbers together. But since this is a string, it's going to instead do a concatenation. So let's say that it is currently, and we want to know what the actual temperature is. So we'll say temperature there. And then we're going to say which is, then we're going to add the difference. And then we're going to say from, and we're going to add our desired temperature. So what we're doing here is we're going to output the actual temperature, and then we're going to say which is what the difference is from the desired temperature, the temperature that we actually want to have. Now, this is a lot of concatenation that we've done here. We have one string here, we're concatenating it with one number, and then we're concatenating it with another string, and then another number, and then another string, and then another number. And remember, all of these numbers are inside, they are the values inside this variable. Let's go ahead and run this, and you can see here that I do in fact get, it is currently 65, which is minus 5 from 70, which is great because it gives us an understanding that all of our values here are what we expect them to be. So this concatenation now, you can play around with this and do different things. Let's just, for fun, I'm going to make a new one down here because I don't want to mess this one up, but I'm going to do a new one just to kind of illustrate some of the fun things that you can do. This, of course, is no longer concatenation, right? This is now addition because these are two numbers. So if I add this, I should get 16, and I do. Now, how about this? What do you think will happen if I do this? This is, I'll give you a moment to kind of think about it before I hit go, because this is one of those cool moments where you can hopefully have a little bit of aha before I actually do it. Now, if these were numbers, of course, I would add them, but they're not. Now they're actually two strings. Think about it like a zip code. A zip code isn't actually a number. Like, you don't add zip codes together. You're actually representing alphanumerically just some numbers, right? And that's kind of what we're doing here. So this is actually string concatenation because I've put quotes around these two things. So they are in fact strings, and I'm going to get a 313, which I do over here. That's something that's interesting to play around with as you're
you're going through. If you have any questions, definitely throw them in the comments. I'm going to create a frequently asked questions section by pinning it to the top of the comments so people can find it really easily. So definitely check there first. Now that we've been playing around for a while with this console log, I really don't need this. I'm going to remove that. Let's jump into the meat of what we actually want to do with our algorithm. So remember, our algorithm now as a thermostat, remember it's only doing this once yet. We haven't gotten into the next step, which is iteration. That will be coming up very shortly in the next video. For right now, we just want to have our algorithm check the temperature that it is currently against the desired temperature, that difference that we have up there, and based upon the difference, make a decision on whether it needs to turn on the heat, turn on the AC, or do nothing at all. And when we were doing our pseudocode, we represented that with an if statement, and that's exactly what we're going to do in JavaScript. The only difference here is that syntactually in JavaScript, you surround condition you're checking in parentheses. So the way that that looks is like this. I'm going to be checking the difference, and I want to know, in this case, if the difference is less than 0, because this is going to be the block of code where I turn on the heat. Now, I want to talk for a moment about these curly braces. These are also part of the JavaScript syntax. And by the way, I also provided a link to the basics of the JavaScript syntax on the W3 School site, which is a great site, by the way. I highly recommend it for continuing your learning and finding great entry-level tutorials to build off of. What this is basically creating a block of code. Everything that happens between the open paren and the close paren is the code that's going to be run if this if statement is true. If the if statement is not true, then we would run the next line of code here. Let's just play with this for a moment. Let's put here console.log, and we'll just put after, because I want to denote that this is after the if statement. And here we're going to put console.log, and we're going to put inside. Let's just put inside so we know where we are. And notice here that this will happen if the difference is less than 0. Let's go ahead and run this and see what happens. All right, so this is good. So we have inside, so this line of code ran, and we have after. So that means this line of code ran. Now this was expected, because if we go back and we remember what our difference was, our difference of 65 minus 70 is -5, right? So -5 is less than 0. So this is true. So we go in here. Now, just for fun, let's make this 71, right? Now, what do you think is going to happen? Do you think that we're going to see both of these statements? Let's find out. So I run this. And notice the inside went away and the after is here, because in this case, we skipped everything in between these two open paren and closed parens because this was not true. So you go down here and you continue on your merry way. This just happens to be the next line of code that is outside that block, so after the closing parenthesis, so that is the next thing that is run. Just as an aside, remember we talked about if and then otherwise if. So that is equivalent here to else if. So if I type here else if, and then I type, say, difference is greater than 0. Let's put that here. So this is going to be, let's change these now. Let's put what we're going to have happen in here. So this is going to be AC. This is going to be heat. And actually, you know, I want to put one more here. We're going to put else if, and then we're just going to put an else, and I'll explain this as we go. So this one here is what's going to happen when the difference was not less than 0, or the difference was not greater than 0. So that means the difference had to be 0. There was no other possibilities. We've taken care of the whole range of numbers below 0, the whole range of numbers above 0. So that means the only other reason that we could possibly end up anywhere else, and that's why there's no if. So else is what happens if all the ifs fail to happen. If the first if is false, if the second if is false, then we end up here. Then we'll just say just right, because the temperature is exactly where we want it to be. Notice that this is going to happen no matter what, because even if
this one was true, or this one was true, or neither of them were true, and this happened, you're still going to end up here. Because we have the else here, though, it's important to note that one of these three will be displayed no matter what, because if neither of these is true, we'll end up here. Also remember that if the first one is true, you don't check these. You just jump right down to here. If this one is false, but this one is true, you do this, but you don't check the else, right? You only get down to the else if both of these were false, and then you definitely run what is inside the else. Let's go ahead and run this and see what happens here. So notice here is currently 71, which is 1 from 70. It turned on the AC, and we got to after, which is exactly what we expected it to do, right? Let's put this back to 65 and run it again. And now notice here, it says it is currently 65, which is minus 5 from 70. It turned on the heat, and we got to the after, which is exactly, again, what we expected. Let's try the last scenario here, which is 70 degrees and 70 degrees. So the thermostat has accomplished its goal. The temperature is correct. We run it, and it says it is currently 70, which is 0 degrees from 70. Temperature is just right, and we still have the after. So congratulations, you have written your very first algorithm. Now, obviously, there's a lot more that would be desired here for a real thermostat. We don't have a sensor giving us a temperature. We have to manually set the desired temperature, although that's not so horrible here. Like I could do that here and run it, and we'll obviously turn on the heat because we've raised our expected temperature. You've built your first algorithm, so congratulations. The big things we learned today were statements. So remember, a statement is a discrete action within our program. We have here a assignment to a variable. So remember, these are variables here, and they are assigned values. In this statement, we actually assign a variable based on the difference between these other two variables. We learned about console log, and more importantly, we learned the very beginnings of what this thing is, that we're actually using an object that's provided by the JavaScript programming language called console, and we're using what's called a method on that object, and the method produces an action. I provided a link where you can look to see what the different methods that are available for that object are. That's in the resources at the end. And we use that to provide ourselves output. And within that, we saw that we can output strings by using either single or double quotes. I stuck to single quotes here. We learned that we could do something called concatenation, which is this idea that we're going to put together different things. So it could be actually multiple strings. People do that to break up lines to make them not so long. In our case, we were doing it with strings and numbers, right? So here's a string, here's a number, because remember what we're showing here is the value of the variable. And we did this multiple times. We learned here conditionals, right? This was a very big one. So this was probably the biggest one of the day. We learned about if statements, else if statements, and else statements. Now, remember, we talked a lot about the fact that the else if and the else only get checked if this one was false. But if we remove this else, then we've actually separated these two things. This is a standalone if statement, and this one's going to be checked no matter what. Whether this is true or false, this one's going to be checked. Not only that, but this else is no longer predicate on the difference here. All right, congratulations, and your reward is more work. So all joking aside, a few things I want to mention as we wrap this up. First is, as I mentioned in the beginning, please introduce yourself in the comments. I'd love to meet you. I'd love to also hear a little bit about your goals and your background. And if you have any suggestions, I'd love to hear that too. Also, if you've gone a little bit further than just following along in the demo and you've created a different algorithm, a different program of your own, please post that. I would love to see it. And I think others will gain from the experience of seeing what you've created as well. Additionally, I have a couple more videos that go along with this lesson. The first one is what is a system? This video explores systems from an engineering perspective of any type of system. It allows us to understand what systems are made of, how to decompose them, and it goes along with the second video, which is abstraction, because computer systems are so complex. As I mentioned earlier in the video, we use abstraction
in order to manage that complexity. Abstraction allows us to have easy to use interfaces that allow us to use systems without fully having to understand how they work. These concepts are absolutely crucial to everything that we're going to be learning throughout this series, so please take a few minutes and go through them now. I also want to show the references that were used here. A couple of them at the end here we talked about while we were doing the coding. JavaScript syntax link is there, as well as the JavaScript console object. I also want to give another shout out to OSSU, as I think that is a brilliant program. It's an open source initiative to create a computer science curriculum online. They even have cohorts now of student groups that go through the classes one at a time. I absolutely highly recommend this. There's additional links here that I think are helpful, that TED algorithm video that I mentioned, and also a link to CS50, which is a brilliant introduction to computer science as well. So I hope you have a great day. Please consider subscribing to get an update on when the next courses come out. As I mentioned earlier in the video, my channel creates all levels of computer science content. So don't be alarmed if you see the next video come out and it's a lot more complicated. There will be more content for this series as well. Look for the CC100 series. I hope you have an absolutely great day, and I hope to see you again in future videos.